I apologize for the weird angle of the camera, but I'm trying to get my scope in here. So I recently purchased and received some really cheap analog vibration sensors. So I thought I'd test them out, see how they work, and I thought I might as well make a video about it. I'll show you which ones I got. These little black ones are, they have a center pole and then a little coil that runs around it. It must be like a spring. So when you tap it, it connects the two. This one's fairly similar, but it's a horizontal, not a vertical mount. I don't know which axis these are sensitive in, so that's what kind of I'm testing today. These ones mount this way, and they have a little spring that sits and vibrates against a piece of metal on the other side. It looks like they tighten the spring up on the other side, so it's got like a heavier. No, I don't see how those are going to work very good though. These seem like they'd be sensitive because the rod is in the middle. This one, the spring has to move a certain axis to hit the metal. We'll see how that works. And these ones, something I've not seen before. And I thought these would be cool because I could probably surface mount them too. Well, I don't know if you can. They probably will melt, but you could probably get them to go sit on a board that's not through hole. And these look like maybe they have a little ball inside of them or a little lever. These are really small. It looks like they're supposed to sit flat, but we'll see. They feel like they might be very sensitive, so these might be promising. So that's what I got. So I went ahead and built this little board, and I'll zoom in here. I just built a little test board. I just put a bunch of headers on it, and these are for my scope and some power rails. Put a light sensor on there, CDS cell, and then I have this one. This one I really didn't feel like it was going to work on that orientation, so I put one hanging off the edge here just to see. And when I was banging on them, they seem to have like a very large variance in sensitivity. See it moving? That one doesn't move as much. So I don't know if I overheated it or if it's just the tolerances in here. So then I got one of these tall ones and then one of these other ones. And I got these little vibrators too. Little vibration alerts, kind of cell phone motors or something, pager motors. I bought a bunch of these, and I was going to test those out as well, so I just put them on this board as well. So this is like a physical interaction board. But then I just realized I could use the motor to test the response of these switches. So that would be cool. See how it bounces? I'm gonna get these out of here, they're too shiny. Over there. Alright, so let's hook this up and test it out. Gotta remember what's what now. We can do this by... Okay, so we'll just do... We'll hook these colors up to the scope probe colors. So we got yellow. Whoops. Oh, come on. Jeez. Yellow, blue, just use green for now, for pink. And I only got 2 scope probes hooked up. Maybe I'll get another one. I'll grab another one. Or we'll just switch it back and forth. I think this one is... We'll just do that one. We'll figure out which one's which later. Let's just wire this up like this. We'll just put them in order. How about that? We'll put them in order. I'll just put these in order here. You know, some of these crappy DuPont connectors, I noticed if you put them in sideways, they bend them out of shape and you can't use them again because they're just very badly designed. Should be uniform, both directions, but it's not. Alright, so we got yellow, blue, green, which is pink. And I think this yellow is the small sensor, blue is this sensor, green is this sensor. This one's not attached to anything. I could just put a scope probe over there if I want to check the difference. And the motor's connected to these 2 here. Alright, so I probably need a ground for my scope, and I need power. Hopefully that's not in the camera's way. Well, kind of is. It'll be fine. Of course, I made these the other day, and they are... I need to make the other kind because these are the opposite of what I need. Alright, so we got positive and negative. I'll just use this one here. Let's see, we'll use orange for negative and red for positive, of course. And then we'll hook those up to these guys. Alright, so we have our positive, negative. This is the common... Wait, no. That's not right. I think I got these backwards. Alright, this goes like that. Yeah. That goes like that. Hold on 1 second. Alright. So I like making little test boards like this. I really enjoy this format. It lets you do a lot of stuff with a little bit of space. And I make up little jigs like this all the time when I need to test something. I got little breadboards with all different variable SMD components on it. And I got the test jig that I use for testing my buzzers and all that stuff. So just throwing something together real quick. This didn't take me long, a couple hours. And it's a good reference design for when I go back to, checking these out again. I'll just throw it in a bin somewhere when I'm done with it. The good thing about this one, I built it to break out these pins to scope probes, so I can use this board for other stuff as well. And for just, breadboard breakout, some power lines. Alright, so there's that wired up. We just need to wire up these sensors. This one here is the common. We'll just use this blue one over here. Blue. And then we're going to put the blue on... I guess we need to do positive so that the scope can see it. This one's not very good. That's not going to work. That connector is shot. Let's try this. We'll just use this gray one over here. Oh man, what is up with these connectors? It's like once you put them on, they bend out. They bend and they don't fit ever again. Very cheap. So we'll put that over there. I don't like that one. I should have put one over there. I have some short ones. I don't know what I did with the short ones for female to female. So we'll just have to deal with that for now. Negative, positive, positive, loops back through to common. Common goes to the common for this one, this one, this one. All right. Okay. That looks like we're good to go. Let's go ahead and hook some scope probes up. We'll do yellow, blue. I'll add another one if I need to. For now, that's what we're just going to hook that up like that. Let's see what my sweet spot is. That's pretty good. All right, I'll put this on auto so we can see what's going on here. Speed it up a little bit. All right, I think I have it set to data and clock, whatever. I can name those which sensor it is, but we'll do that later. All right, so let's check it out. I should probably use a quiet power supply, but I need to control this one, so... Oh, we didn't hook the motor up. Let's go hook the motor up too. I'm gonna need a negative to the motor. And the only problem is changing the voltage to the motor is going to change the response of the sensors. It'll be alright. I'm not going to go ahead and use dual power supplies right now. This is going to be crazy. And then we put a positive to the other side of the buzzer. I don't know if there's a polarity here or not. Maybe I should do positive. That'll work. It says that's the red one. That should be okay. Let's make sure it works real quick. We'll turn this down to 3 volts. We'll turn the current limit down to maybe, I don't know, 20 milliamps. Oh. It looks like the motor takes a 3 volts, 72 milliamps, 3 volts, 3.3, about 80. We'll use 3.3 as a standard here then. Alright. Looks like it turns on at it's probably supposed to be pulsed. I'm just powering it straight up. Looks like it turns on at like 12 milliamps. Or 3, but it doesn't really do anything until about 30, 20, 30. Right, we'll just leave it on that then. And we'll unplug that one for now. Okay. Alright. Let me get another scope probe. These are my Rigol probes are still packaged up. I never took them out. Let me take these these Tektronix. I got some pink rings. How convenient. All right. We'll just use this one then. Alright, pink. Pinkens your teeth while you chew it. This is all tangled up. I bought some of these, God, what are these probes? They're not these are 12 picofarad TPP0101. I got these for really cheap on eBay. The capacitance is a little high, but they're really nice probes. Let me tuck this into here. Sometimes you almost want stiffer probes. These Tektronix ones are so soft. I can't even get it to move. It just goes where it wants to go. That's what happens when you gotta hang your probes, because when you leave them curled up, it turns them into a mess. So we'll just get this organized so it's not all over the place, because I'm gonna have to be moving this around. I probably should have tethered this to this board. Alright, so channel 3, what's the 1 volt? We'll set it to 2 volts also, so everything's the same. It's really pink, not purple. So the problem with this scope is the pink is pink and the blue, dark blue is purple. They both look like they're purple. And a lot of people complain about that. Alright, I'll set the purple to 1 volt. Why is there so much noise on this probe? And yeah, look at all that noise. That must be from my lights. I forgot that LED lights are going to really cause problems. No? It's not from my lights. Well, some of it is. Yeah. Ooh. Well, we're not doing any high speed today, so we should be fine. Huh. That's 10 microvolts. Alright, let's set these all 2 volts per division. We're going to set the time base to, I don't know, 500 microseconds, 200 microseconds to start. That should be good enough. Let's see. What's the trigger set to? Slope. I don't know why sometimes it doesn't show the trigger level. Does it only show the trigger level when you're in DC coupling? Yeah, it does. It's kind of annoying. Oh, I'm not really getting a lot of response out of this thing. All right. Looks like all 3 sensors detect that. All 3 sensors detect a nice pounding. Bump that trigger up a little bit. Looks like the this one's the most sensitive. So we'll use that as the trigger. Wish I had a piezo. I could hook up a piezo and use that as the trigger. It looks like these ones barely register, probably because they bounce so much. It looks like the ball. It's interesting. It looks like the ball one might stay normally closed most of the time. Looks like you can detect the ball one on closed and open. That might not be the best because it's probably going to use. It might use current when it's closed, when it's not detecting. Yeah, it feels like it maybe sits there and connects the circuit and then breaks when it. Well, let's see. What do I have? Channel 1 on AC coupling. We'll do DC. And 1.6 volts per. No, it definitely goes high, but sometimes it stays high. Sometimes it stays high, so it definitely is something rolling around in there. Probably a ball. It's connecting. There's probably a ball in there that's connecting the circuit, because it seems to get stuck sometimes. The other ones don't do that because they're springs. But they also trigger much less. I don't know if it's just I can't catch it. I hope my power supply is not too loud. All right, let's trigger on channel 2. Channel 2 I think is this one. Alright, we'll put it on normal. No, sorry. Channel 2 is this one. This one right here, this orientation through hole to the board requires much more to trigger it. It's not this one, it's this one. Much more. Looks like the bandwidth really sucks on the scope when you got more than 2 channels on. I'll turn channel 3 off. There also seems to be some bounce. Let me turn the time base up. Alright, looks like you're going to have to detect these spring ones really fast. The only way I can even detect it, you have to put a pulse stretcher on it. Or have a pin watching it constantly that's got a really short trigger window. I'm on 10 nanoseconds and I'm barely picking it up. I'll go to 1 microsecond. I can get it to trigger, but you gotta tap it. If I tap it this direction, alright, let's take this one off here and let's check this one over here. I think this one goes, yeah, there. See if it's any more sensitive being hanging off the board like that. It's a little bit more sensitive. What if I put it at an angle? Yeah, I don't really understand what you're going to use these spring sensors for, unless these ones are just rejects. I'd like to get the one from Adafruit and see if it's any better. I mean, it's detecting that pretty reliably. It almost seems like it'd be really good for detecting a knock. Yeah. If it's coupled to a surface in the right orientation, or mounted on some kind of mass that can move, it might work better. So I'm not really sure how you're supposed to use these sensors. I'm gonna have to look them up and see what they suggest. How many pounds of? They seem to be very orientation dependent. Like that's not doing anything. You'd think that would be triggering something, but let's try it this way. No, nothing. More. Let's try it this way. No. In some directions it won't even trigger. Upside down, it won't even, because the spring's fallen away from the head, it won't even trigger. So if you're going to use these, I would use maybe 2 of them in different axes, and you're going to either want to have a pulse stretcher on them if you want to detect anything, reasonable. I mean, you might just want to detect if someone drops something or someone bops something like. I mean, that works. It works good for that. But this ball sensor doesn't work like that, I don't think. I think it works completely different. So I'm going to put this back over here. And we're going to test this ball sensor now. I'm calling it a ball sensor. I'm going to rip one open and see what's actually inside of it. Alright, so alright, it seems to be fairly sensitive. A lot less sensitive than the other one. I think it's sensitive in different directions. Yeah. Super sensitive when you have it in this orientation. And even more so the opposite. On its side, still pretty sensitive. It's just constantly triggering. I'm barely touching this and it's triggering every time. This detects anybody touching your stuff. This is really sensitive. I really like these sensors. So let's try this third one. This one seems to detect, well, let's try upside down. Oops. Not as sensitive. That makes sense that it might, if it's a ball or a lever, a weight. It's not as sensitive upside down. Probably about 30%, half as sensitive. So this switch is great for three different, almost every orientation, but upside down. And I'll test some more to see if that's actually true. Maybe I'll put those on their own board, use two of them, and measure each one. Alright, let's put channel 3 on, and we'll turn channel 2 off because we don't care about that guy. And then we're gonna set triggering on channel 3. Whoops, not 4. That's why I put this big knob on here. It's still, I gotta put a piece of rubber band around there, something to slow it down. Let's see where 3 is at. 3 is, what's the coupling on 3? Let's do AC. Do AC coupling on 1, 2, and then we'll move. Oops. Move 1 out of the way. Move 3 down. Let's go ahead and put 2 back on 2. Looks like the time base for the looks like the time base for this one's a little different. We'll set it to 500 nanoseconds. That's probably because I have. Let me just turn all these channels off, except for 3. Yeah, I'll do that. Looks like it's a very brief pulse and very low amplitude. I don't know if that's because the voltage is so low. We probably need a higher voltage with these sensors so that I can, you know, bridge better. Maybe I'll test these at 5 volt and see what the difference is. This sensor is really strange. It's definitely like if you hit something. It's like in between the two. I thought it would be more sensitive. It's really good at detecting vibration, like a actual resonance. This would be good for detecting something wrong with the motor. Shutdown for a motor, maybe? Because it's a long, tall spring. Any movement causes it to trigger. It looks like the contacts are not very good inside of it though, because the response is very low. Alright, let's turn these other channels on. And we'll zoom out so you can see them all. It's interesting because the things that trigger, I think that just time base is a little different. There's probably a lot of bounce, so it's hard to capture all of them. We'll put them on auto. I wonder what else I could be using to do. I could do what if I put this on roll? Yeah, roll's pretty good. So there you can clearly see the difference between. I'll zoom back out and redo all these again so you can see them as well right after this.
Since I'm not really set up to screen capture my oscilloscope yet, I gotta figure that out, how to do that better.
Nothing's detecting this. So, of course, my bandwidth on this is not the best when I got 3 channels running. So you can see that purple one really sensitive. Let me make sure I got the right probe on here. Yeah. Okay. Make sure I got 10x on. Now if we shake it, the yellow one's detecting better. The yellow one also is really good at detecting rotation. It looks like I'm getting a little bit of sense on these two on rotation as well, but it's very small. It might not even be there. It might be from this sensor. Let me take the yellow off and see. I think it's just crosstalk. Yeah. That's not actually detecting that. That's just noise. See that those little blips on the bottom and the purple and blue are just noise from this one. You probably want to put a capacitor on these if you have them near anything. Yeah, see, look, that sensor's really good at detecting roll. Anytime you move something, I really like those. Purple one's really good at detecting taps, if the thing was bumped or jarred. And this one right here is really good at detecting being smacked. See? And that could just be the time base too. Because we're in roll mode, it's not very if I did XY, what would that do? That's cool. I guess you could figure some way to plot that. So we'll just do YT again, and yeah, you can see how low the amplitude is on this sensor. It barely detects. And I feel that sensor is not as good. I think some of these are good and some of these are not very good. If I put this over here, it's much more sensitive. I think there's something wrong with that one. Yeah, look at that. Now I'm getting great response on that. Well, let me I don't know how to capture that. It's happening before. Yeah, see, look, it detects that knock and then it resonates. So I'm going to have to change the hold off so I'm not picking off these second ones. What is that? Yeah. I might have to set a larger hold off. Trigger setting. Actually, I don't know. Maybe I have the I'll change the hold off first and see if that makes a difference. We'll put it at 100. Put the hold off at 100 microseconds. Whoops, what are you doing? I hate this input method. It's the worst. This is like the most sensitive knob, and that's the one they use to much better. Alright, so now we're detecting a little bit better. We're not detecting the second. Actually, we are. Let's change this to 130 microseconds. That's a little better, but whatever. For now, that'll work. We could also put this on deep mode, and then we can zoom in and see each one. Yeah, these sensors are a little whiffy. You'll have to play with those and see what the you have to play with these sensors a little bit more and see what exactly their forte is, because let's go ahead and change the triggering to, we're triggering on 3, let's trigger on 2. I wish you could just press trigger and then the button instead of having to go in this menu and change the stupid thing. The interface is not very good on the scope. You should be able to just change the trigger channel. Alright, so the pulse length on these spring ones are very short, so I get much better response if I trigger on it. And you can see it's triggering way before these ones are. I wonder why that is. That would indicate that it's more sensitive, but it requires a certain threshold to set to overcome that length and that weight, that inertia, whatever. Why is it not triggering? Hello? Something wrong here? See, they're just not very accurate. They're very iffy. I'm not sure how I feel about that. Yeah, if you want to detect jostles and knocks, these are really good. If you want to detect someone bumping your case, oh shoot, it's so annoying. Someone just touching your stuff, bumping it, or vibration on something, resonance. This one works really good. If you want to detect everything, including movement, and this one's pretty good at detecting movement, but only if it's in like a non-gentle way. And that makes sense, it's a spring. This one is a ball. I think this one's a ball or some kind of pivot so that it detects any movement whatsoever. Even if you're gentle, if you try to like be secretive. So I mean, that's kind of cool for these probably 10-20 cent sensors. You put all 3 of them and you can maybe detect what kind of action you're detecting, what kind of inertia and force is being used. So you can detect something's being picked up and moved, or something got dropped, or something got pushed out of the way, or something's getting bopped. And that's very low tech. You don't have to use anything beyond that. Now, a piezo might be better for that if you're going to do something like that, but I mean, maybe a combination of 2 different kinds of these sensors will be useful for some basic detection. As far as alarm systems go, you have to detect what you want to detect. You don't want it going off all the time. So if you're going to use a sensor on like a window, if you're not going to use a magnetic slide or some kind of knock sensor, you want to use probably these ones. Alright, let's let's go back to that one. Let's do that all over again. Because it was zoomed in. Alright, so again, channel 1. Channel 1 is this ball sensor, and you can see how it just detects anything. Let me turn that up. Actually, I still have the hold off pretty high for that other sensor. Bring it back to 40 microseconds. Nanoseconds? Should it be nanoseconds or microseconds? Hold off. I don't know what hold off should be when you're just testing stuff. See, yeah, you can see how sensitive this is. That yellow trace is what we're triggering on. Now the purple detects it a little bit, but only if it's a little more. So we'll go back to triggering, we'll put it on channel 2. I mean, sorry, channel 3. I should reorganize these, huh? Well, we won't do it now. Blue is channel 2, and that's the sensor over here. We can detect the knocks pretty good. It's not detecting that. And you can see it kind of picks it up before some of the other sensors do. Doesn't do very good vibration. But it'll detect a knock pretty good. Yeah, so it detects knocks pretty good. We'll go ahead and go to channel 3. Oops, damn it. Channel 3. Channel 3 is this guy right here. It's good at detecting something getting bumped. It's a very good vibration sensor, like. Alright, so let's do a motor test now. Since this is the most sensitive to vibration, let's trigger on that guy. Whoa. Alright, let's turn this up. Alright, so you can see how these two sensors are detecting all the time. And then now and then your channel 2 will trigger. See? And that might just be my triggering. Let's bump it. Let's zoom all the way in there. I have a feeling if you overdrive that motor, it's gonna... Oh, the sticky came off. It wasn't very... There we go. It wasn't... Yeah, I don't think those are very good motors. I think they'll burn out real quick. There we go. That's what we want to see. Now, some of that could be noise. but the amplitudes tell me it's probably vibration. And if I oops. Let's go ahead and trigger on channel 3. Keep doing that. I wish it was that easy. Alright, so if we trigger on channel 3, we're triggering constantly. That motor's barely spinning, and it's triggering. Let's see, we're at 20 milliamps on that motor. Just a little hum, barely vibrating the board, and this sensor's picking it up all the time. So it's triggering constantly. So let's go ahead and put channel 1 on. Trigger on channel 1. We could trigger a little lower. There we go. And it's picking it up too. See, that's why I wish I could pulse this motor and see how sensitive it was. That's detecting down to 16. I'll turn this voltage up to 5. Alright, so we're triggering. So I believe we're triggering on the vibration of these sensors, not any noise generated from it. I guess I could take the sensor off the board and I can double check and make sure it's the vibration. It seems to be, because if I hold the board and move the board and I touch it, and it seems to dampen it a little bit, which it shouldn't do for noise. Yeah, see, it doesn't really change. So it could be. I'm pretty sure that is the vibration. Because if you turn it up, which one are we triggering on again? Channel 1? Let's do 2. No, let's do 3. 3 seems to be yeah. What if we put this on roll? It's going to be useless because if we do it on roll, then we can see the frequency change, and then we can pull it off. So you'll have to use a really good triggering or some kind of RC charge circuit that can detect how much motion there is. So detecting one single knock might be pretty hard. So If there's anything I missed and you want me to test something else, let me know. Or if you see anything online that's different than these three. So it looks like each one has a very limited use case. Maybe I can find data sheets on them if I dig hard enough. So that's just a quick synopsis of these three vibration sensors. If you want to see something else, let me know. If you want me to look at detecting this maybe with an Arduino, we could try that. I don't know what kind of interrupts speed we can get on different microcontrollers, but we could always set a little RC circuit up to check the to see if we can make better use of these, because they're very cheap. So I could see a lot of potential for these in a project. So let's go ahead and take a look at these ones. I really want to see what's inside of them. I'm just going to use a razor blade to cut. This looks like heat shrink, actually. Very good heat shrink, apparently. I think that's... Oh, look, there's two balls inside. I was wrong. Not just a ball, it's two balls. That's why it's so sensitive. And it's literally just a plastic cage with a metal cup. And two little balls in between them. And the plate goes on the other side, and they just kind of detect any direction. That's why if you put them, so they should be the same both directions, but I seem to see a little difference in there. So it's just heat shrink around this little core. You could probably make one of these, and inside it's just got two balls, a little plastic frame, and two identical metal cups, and it just detects those balls rolling around. So that's why this one can sometimes open and close and get stuck like that. And it seems to be the way these balls fit in here, they could have different orientations, could lock up or not work as well. But that's also why it's so sensitive. I think having a sensor with a combination of a ball and a spring would be very interesting. Maybe even a 3-terminal, so you can detect two different kinds of motion all at once. That would be kind of interesting. Or a ball inside of a spring, and then the spring touches another rod. So there's some interesting ideas you can do. And these are really cheap to manufacture. I mean, look. And it's just held together with heat shrink. So if you were going to put this in a project, you might want to throw a little dab of hot glue or something on there so that it, stays together tightly if you plan on it getting hot. Or they did use fairly decent heat shrink, though. It's very strong. And here's another sensor. As you can see, it detects vibration in that direction, and that has to spring and hit that contact all the way over there. So there's not much to see with this one. It's just I've seen one taken apart. There's a spring wrapped around a metal core. You can imagine what it looks like. In fact, they didn't even put a lead on it. That's the spring. It's a very thin, super thin wire. And then they just
Plus I've got a tube and heat shrinked it.
So that's that for these vibration sensors. If you see any more, let me know. That's it for now. Till next time.